Welcome back to Stuart Science. Today we're talking about acids, bases, and pH. Now pH is the scale that we use to measure acids and bases are just corrosive materials that involve H and OH ions. So the first question that you might see is if you have a pH of this, is that a strong acid or a weak base? So here's a drawing to help us out here. Right in the middle, distilled water is a 7 on the pH scale. That means it's neutral, right in the middle. Now anything less than 7, all the way down to 0, this whole side is an acid. Now, you're probably familiar with acids because every time you watch a sci-fi movie, there's an alien that spits acid and it dissolves metal. So acids can be very corrosive materials. But what they didn't tell you in those movies is that bases can also be corrosive. So the pH scale on the other side goes all the way up to 14, and these are bases. Both can be corrosive, both acids and bases, although you'll never see an alien in the movies that's spitting a base at people for some reason. Now, and 7 is neutral. Now, anything that's in the 7-ish area, this zone here, I'm talking like 6, 5, that's weak, or 8 or 9. Those are weak acids and weak bases. Now 5 and 6 are weak acids and 8 and 9 are weak bases because they're around 7. So when you start getting further out on the pH scale, when those numbers get more extreme on the high side or more extreme on the low side, that's when the acids and bases start to get stronger and stronger. So I think Pepsi or most sodas are a 4 on the pH scale. I think orange juice is a 3, so that's getting a little bit on the strong side. When vinegar is in that zone too. If you use vinegar, you can actually clean some corrosion off of things because it'll dissolve some of the oxidized metals. So we're starting to get stronger and stronger. And then a 2 or a 1 or even a 0, those get very corrosive when you get down on the extreme edge. So this is kind of weak in the middle, around 7, and then it gets stronger as you get out. Whereas 0 would be the strongest acid. I think you can maybe get a -1 on the pH scale if you do some fancy chemistry, but don't worry about it. 0 is as low as you're going to go, as long as you want to go. Then on the base side, obviously, the same thing is true, but the higher the numbers get, the stronger it is. I'm going to just clean this up a little bit. All right, so now that this is a little cleaner to see here, the takeaway is if you have numbers that are 0, 1, or 2, you're in the strong acid category. If you have numbers that are in the 4, 5, or 6, you're in the weak acid category because those numbers are close to 7. So they're not very strong, but they are also less than 7, which makes them an acid. The opposite is true too. If you have a 14, a 13, a 12, those are strong bases because you're way out here on the pH scale. As you get closer in toward the middle, it gets weaker and weaker. So an 8 is baking soda, a 9 would be a chemical cleaner. Those are weak bases. They're weak because they're close to 7, but they're a base because they're above 7. So anything above 7 is a base, anything below 7 is an acid, and the further out you get from that 7 in the middle is stronger. Now, chemically, what's happening here is that acids make hydrogen positive ions. These are called hydronium ions. Increase in the water. And then bases make OH or hydroxide negative ions appear in the water. Now, the chemistry doesn't always work out like this, but a lot of times if you look at a chemical, you can kind of tell if it's going to be an acid or a base. So here's a couple examples of an acid chemical formula. HCl is hydrochloric acid. Notice this H at the beginning. Or H2SO4. That's sulfuric acid or battery acid. Notice the H at the beginning here. HNO3, that's nitric acid. Again, notice the H. So if you see this H at the beginning of a chemical formula, there's a pretty good chance that it's an acid. The one exception would be H2O. That's not really an acid. But when you start seeing these chemical formulas, you can kind of tell by the fact that they've written it in a way that the H is at the beginning. That's a dead giveaway that you're working with an acid. And the opposite's kind of true too. If you have NaOH, this OH kind of makes you think base. Now again, it doesn't always work this way. Some acids will make the H positives increase for other reasons. They don't just dissolve and give it away. But most acids will have an H at the beginning. And a lot of bases have an OH at the end. There are, again, some fancy chemistry, but the questions that you'll see, at least in my class, if I ask you for BaOH2, that OH is a dead giveaway that it's at a base. So to summarize, H positive at the beginning, OH, it's an acid. OH negative at the end is a base. As always, this is Mr. Stewart. Keep learning, no matter what.